All right, so for domain and range is actually pretty simple when we're looking at graphs. Now, of course, we'll talk more about domain and range when we deal with situations. And remember, the situation is going to put limitations on any function that we have. Most of our situations happen in the real world, which means that everything that's going to, mostly values over here are going to be acceptable. Also, a ball cannot hit the ground and burrow into it, so usually we're not going to have anything down here because we're not going to have negative y values. And a lot of times time is our variable. Time doesn't go negative. So most of the stuff that we're going to see in real world situations happens in the first quadrant, which means it's positive, positive, positive x, positive y. That's not always the case, but we'll talk about that more when we do some more word problems. For now, let's talk about domain and range of graphs. Okay, so these are the notes that we took on Monday, so we're going to go back to those and kind of finish them out now. So when we look at domain and range, first of all, I talked about this a little bit earlier. So I talked about this in class today. I gave this example, but I want you to write it down. If your parabola looks like a bowl, you have a minimum. If it looks like an umbrella, you have a maximum. Okay, so if in this case I have a bowl, all right? So my domain for a graph, okay, so when I'm looking at a graph, my domain is all real numbers. That means I can put in any x value that I want to. Because remember, my function machine, I can pick any of the buttons. So if I'm looking at a Coke machine, I can hit any of the buttons on that Coke machine. I can hit any x value I want to. Okay? That's going to tell me what y values I can get out. Now, that means any x, positive, negative, fraction, decimal percent, anything I can put in there. But my y values are restricted. Now, with a linear function, if I put in any x, I could get out any y. But that's not the case with quadratics, because remember, we have a minimum or a maximum. Okay, so if I have a minimum value, that means my y values cannot go below it. If I have a maximum value, that means my y values can't go above it. So my quadratics are naturally restricted in the range. Okay, so if I have a minimum, okay, then my y value is going to be greater than or equal to k, which is the y part of this vertex. So if I look here, if I look at this function right here, my y value is -1. For this graph right here, my range is y greater than or equal to -1. Every y value I have has to be bigger than -1. Now, if this were pointing down instead and I had a maximum, my y values would be less than or equal to k, because if I had a maximum, all of my y values would be here or lower. If I had a minimum, just so you can have the same picture here, all of my y values would be bigger. Okay? And really, this is it. That's it. Remember, our x values, our domain is all of the x values that are acceptable. And for a graph, it's all real numbers. My range is not all real numbers because it's restricted by the fact that my parabola turns around and goes the other way, because, you know, it sees the bad guy and it says, oh, no, I don't have any part of that, and it goes the other direction. So it doesn't keep going down. It turns around and goes the other direction. All right? If you have any questions about this, ask me tomorrow in class. We're going to practice this in class tomorrow.